An archer shoots an arrow from a height of 5 feet at an angle of elevation of 30 degrees with a velocity of 300 feet per second. The arrow strikes a target at a height of 5 feet. Write the parametric equations for the path of the projectile, and then we're going to find out some other stuff. Okay, so let's draw a picture so we can visualize what's going on. And we're going to let this info of the angle of elevation and the velocity be represented by a vector. So it's going to be 30 degrees for the angle, and the magnitude is going to be the velocity, which is 300. And then we want to just remember that this is, because vectors could be anywhere, but this is up 5 feet. Okay, so what we're going to want to do is what we very commonly do. We're going to break this down into, make a right triangle and break it down into its x and y components. As I'm looking at this picture, I can see that cosine of 30 degrees is adjacent over hypotenuse, and sine of 30 degrees is opposite over hypotenuse. So x is going to be 300, and I'm going to go ahead and put in cosine of 30. We know cosine of 30 is going to be square root 3 over 2. And then for y, we're going to have 300. Sine of 30 is 1/2. Now, this would be breaking the vector down into its components, but it's going 300 feet per second. So if I want to express this as its position parametrically, I'm going to use this x and y, but I'm going to need to also include time, and also for the y, we'll talk about it in a minute, but we got to include the fact that for the vertical distance, gravity is pulling down on it and will affect the height. All right, so let's first of all write down our parametric equations then. So we've got x of t is going to be, I can reduce these and make that 150. So 150 square roots of 3 times t. Then y of t is going to be, these will reduce as well, so that's going to be 150 times t. We're also going to have gravity acting upon it, pulling it down, and 1/2 gt is for gravity, and the gravitational constant is 32, so taking half of 32, that's going to be 16 t squared. That's the piece due to gravity, and now it started up 5, so I've got to add 5 onto the end of that as well. So those are our two parametric equations that define the position of this arrow at time t, and I'm going to rewrite y just in descending order, so as I think about how I'm going to deal with this, it will be ready to work with. So now that I have the parametric equations, I'm ready to look up here and see what else they want me to answer. So we've got the path of the projectile here with our x and our y. How far away from the archer is the target? Okay, so this went up and it came back down and it hit the target at the same height of 5 feet of wherever the archer was. So if I want to know how far it went, first of all, I'm going to figure out when it's back at 5 feet. And so I'm going to take the y and I'm going to put it equal to 5 to see when it is at 5 feet. That will be able to give me the time it took to get there, and then I can plug it in there to find out the distance. Okay, so those will cancel, leave that 0. And then I'm going to factor out a negative 2t. And that will leave 8t minus 75. So I have t equals 0 and I have t equals 75 eighths. So keep in mind this is a parabolic path it follows, and so there are 2 times it was up 5 feet. This one at time 0, and then this next one at 75 eighths, which I'm going to get as a decimal. It's going to be 9.375. 9.375, that's seconds before it hits the target. And so actually I'm going to mark that because that was one of the questions. How long is the arrow in the air? And it's in the air 9.375 seconds. Now, if I take the 9.375 and I put it in the X, that will give me the distance it traveled, because remember, X is the horizontal distance. So I've already got 9.375 in my calculator, so I'm just going to use that for the t, multiply that by 150 square roots of 3. And I get the distance traveled, or when it hit the target, is about 2,435, it said to the nearest tenth, 0.7 feet. Okay, so I found the time when it was 5 feet. If it was on the ground, I would have put a 0 there and solved it. And then I used that time in the X, which is the horizontal distance, to find out how far away the target was from the archer. All right, so we've answered those two questions. What is the maximum height, and at what time does it reach the maximum height? Okay, this is parabolic shaped when you have a projectile and gravity's acting on it. We know that it hit the target at 9.375 seconds, so if I divide that in half, that's the time it's going to take to be up here at its maximum. So I've got 9.375 and I'm dividing that by 2, and so the time to reach the maximum height, sorry this slide isn't very organized, I'm just trying to fit a lot in with not a lot of space, so I'm just going to put it right here. The time to reach the maximum height is 4.6875 seconds. And the last question was, what is the maximum height? So maximum height, I'm going to take my y, which gives me the vertical, and I'm going to put in that time, and I'm going to see what I get out then for the height. So I've got -16 times that time, which is in my calculator, so I can just use that, squared, plus 150 times that time again, and then plus 5. Looks like my maximum height is 356.6 feet.